problem number 3. In the diagram, BD is 6 kilometers. Alright, so we can mark that on here. 6 kilometers. Alright, and that goes from B to D. Alright, so I'm just going to sort of mark that there. AB is 3 kilometers. Alright, and DE is 5 kilometers. And the question is, what is the length of A to E? Alright, well, there's a couple different ways you could do this problem. There's an easy way and a hard way. Both of them, though, involve the Pythagorean theorem. Pythagorean theorem. And what does the Pythagorean theorem tell us? Well, it says that if you have a right triangle, then there's a relationship between the hypotenuse, and the hypotenuse is the side opposite the right angle, and the two legs. And the relationship is c squared equals a squared plus b squared, where a and b are the legs of the right triangle. Let's pretend that's a right angle. And c is the hypotenuse. And the hypotenuse is always the longest side, and it's the side opposite the right angle. Okay? So, you need to know the Pythagorean theorem. Okay? That's the main thing. And like I said, there's an easy way and a hard way to do this. I'm actually going to show you the easy way. I'll show you that way first. And if you haven't gotten this problem yet, I'll give you a hint. And that hint would be to draw in some extra lines. So I'm actually going to drop a line down from AB, kind of extend AB. And I'm also going to extend a line over here that's parallel with BC. Okay, so that way I get a right angle here. And now you can see another right triangle here. It goes from A to E to this new point here, this new right angle. Okay? So, and you can see since we just dropped this line down straight from AB, and this line over here down at the bottom is parallel to BD, then this has to be 6 kilometers. Right? This over here has to be 6 kilometers. And this, so this is just a rectangle now. And this over here has to be 5. Alright? So we actually have now another right triangle where one side is 8 kilometers and one side is 6. And the hypotenuse is the thing that we're looking for. It's the side opposite the right angle. So we can just use the Pythagorean theorem and say that our AE that we're trying to find squared, because that's our hypotenuse, is equal to A squared, which we could take A to be this 8 kilometers. So we get 8 squared plus, and the other leg is 6, so 6 squared. Okay, so AE, if you take the square root of both sides, is the square root of 64 plus 36, which is equal to the square root of 100, which is equal to 10 kilometers. And that is the easy way to get the answer. Alright? Now, another way that you could look at this problem is you could see this as two similar triangles. So you could say, well, you know that these are vertical angles, so these two angles have to be the same. And this angle and this angle are alternate interior angles of, these are essentially two parallel lines, right? So these are similar triangles because they have all the same angles. And so since you know the ratio of AB over DE is equal to 3 over 5, Okay, that means that the ratio of all of these sides has to be 3 over 5. Okay, so now I'm telling you this is quite a bit longer to figure out. So I'm going to kind of skip some steps here just to kind of show you how you could do it this way. But you know, it's always good to look at things from multiple ways before you dive into a solution. And oftentimes thinking outside the lines is a good way to do it. So, you know, draw extra lines, and they don't have to be within the figure, right? So, so let's just go ahead and do this. So we know, I'm actually going to call this x, and I'll call this y. Okay, the length BC and CD, I'm going to call them x and y, just because it's quicker to write. So x over y also has to be equal to 3 over 5, okay? Because the ratio of the sides has to be the same in a similar triangle. And we also know that x plus y is equal to 6. So we could write this as x is equal to 3/5 y, and substitute that into, whoops, 3, oh, I gotta erase that. We'll just substitute that in for x over here and say 3/5 y plus, I'm going to write it as 5/5 y equals 8/5 y. Whoops, that y should not be on the bottom. Looks like it's on the bottom there. 8/5 y, and that should be equal to 6. So y would be equal to 30 over 8, which is equal to 15 over 4. Okay? So x has got to be equal to 9 over 4. Okay? So that they add up to 6, right? 24/4. That's 6. All right, so now we know now we know this is 9/4 and this is 15/4. Okay, then we can apply the Pythagorean theorem, and we can find out this length here from C to E, and this length here from C to A. Okay, so we have to apply the Pythagorean theorem twice. It gets a little messy, but essentially we could write this as AE is equal to the square root of 3 squared over 9/4 squared, which is 9 plus 81/16. Now that's square roots over the whole thing. Okay, plus the square root of, we have 5 squared, which is 25, plus 15 squared, which is 225 over 4 squared, which is 16. Okay, I'm just taking this leg squared and this leg squared. Okay, now, so like I said, this is a lot more, it's a lot more difficult this way. So let's see, this is equal to 144, oops, that's supposed to be 16 plus 81/16. Okay, and this is equal to 400, oops, didn't want me to put an equal sign there, to put a plus. So this is equal to 400/16 plus 225/16. All right. And so then we get 225/16 square root plus 625 over 16 square root. So that gives us what? That gives us 15 over 4 plus 25 over 4, and 15 and 25 is equal to 40 over 4. So you see we get the same thing that we got before, 10 kilometers. Whew. That was a lot more work though. A lot more computation. So, you know, consider your options, and you know, think outside the box, or whatever the figure is. All right, so there you go. There's the answer, 10 kilometers.